One of the things that makes it harder to learn to code is that it's difficult to visualize a program as it's running, i.e. the process. Now you can look at the code, and that certainly helps, but it's just not the same. Not being able to see a process as it's running is sort of like trying to fix a car without being able to see under the hood. Now, it's not impossible. That's what the Click and Clack brothers at Car Talk do all the time. But they are experts, and even they have mixed success with that. If you really want to understand how programs work, and more specifically, how your program works or doesn't, then you want to be able to see how it works when it runs. Luckily, there are tools that will help you do that. But first, let's read the comments from Dmitry Ivanov. And he says, "Hi Toby, nice lecture. Thank you." A lecture? I'm not sure what to think about that. I could not imagine when I started upgrading your Emmet library to Emmy that I will watch videos of you in the future. So Emmet is a very, very little known JavaScript emitter library that I wrote. And it looks like Dmitry has taken that and kind of ran with it. And I cannot imagine that a library that I didn't even tell anyone about would get picked up by someone and inspire them to do something. And I think that's really awesome. That's the power of the internet. So I'm very happy about that. So Dmitry goes on to say that concerning the question you've asked, one of the last tutorials I've taken was Shader School from noteschool.io. And he says, happily this workshop is not installable anymore through NPM, which NPM usually makes it easy to install things. So the criteria you've mentioned are naturally created. It is already slow in study, difficult and experimental due to in order to use that, a user should recreate the WebGL environment of the workshopper manually. So from the course maker's perspective, I think it's not a good idea to make the setup process difficult for your student because then they can get stuck and get discouraged even before they start learning. More broadly, I'm also not saying that the harder a course is, therefore the better it is going to be. What I mean by difficult is better is more from the learner's perspective, being mindful of the fact that just because you have gotten through the material easily, that doesn't mean you've learned it well. Given the choice between having learned something easily versus difficultly, choosing the more difficult route is actually better. Now, there is such a thing as having something that's too difficult for you because then you're going to get stuck. When that happens, you want to find a slightly different route that's actually a little easier for you. The trick, therefore, is to find a difficulty level that's just right for you. From a course maker's perspective, it's very difficult for them to make one course that tailors to the needs of all their students. But maybe that is where artificial intelligence can help. But until we're there, and that actually works well, finding the right difficulty level is something that you just have to be conscious about. And that's also something that your mentors can help you a lot with. Thanks for the question, Dmitry. Now, on with the show. PythonTutor.com is a tool designed specifically to help you visualize what your program looks like as it's running. And despite its name, it actually supports multiple programming languages, not just Python. So let's see it in action. Let's start writing and visualizing code now. So I'm in this code editor, and in this selection box on the top, I can see that I have access to a number of different programming languages, including Python, Java, JavaScript, and Ruby. I'm just going to stick with Python. And to kick around the tires a little bit, I'm just going to write a simple program that takes the average of a set of numbers. So for the audio listeners, I'm going to read off each line of the program as I type it. So for line 1, I'm going to type scores is equal to, open bracket, 6, 5, 7, 8, 10, close bracket. That declares a list of numbers and stores it in the variable scores. Line 2, I'm going to write sum equals 0. That initializes a sum variable, which I want to add to as I go through each individual score. Line 3, for score in scores, colon. Line 4 with an indentation, I'm going to write sum is equal to sum plus score. Okay. Next line, line 5, I'm going to calculate the average now. So line 5 is going to be average equals sum divided by len of scores. So the len function in Python, len, gives you the length of an array. So I'm just going to use that to get how many scores there were in the list of scores. So dividing the sum of all the scores by the number of scores there are, that should give us the average. Finally, line 6, I'm going to print out the average. So I'm going to say print, double quote, average score is colon D for numeric substitution, double quote again, and then I'm going to put the % sign here to do variable substitution into the string. And the value I want to substitute in for %d is average. I think that should work, but if not, we will also find out. So now I'm going to click on Visualize Execution. So this is the visualization screen. On the left of the screen, I see the code. There's an arrow next to the current line of the code. At the beginning, that's going to be line 1. Underneath that code, I see these VCR buttons, these forward and backward and fast forward buttons. These allows me to step forward and backwards through the execution of the code line by line. On the right side of the screen, I see frames and objects, but currently it's empty. We'll see those in action soon. So let's step through this code line by line, starting from line 1. If I hit forward, now I'm at line 2. And that also means it has just executed the code on line 1. The result of that is on the right side, under the frames section, I now see a global frame, and in it is a scores variable. And the value of that scores variable is a pointer, and that pointer points to a list in the objects section. And that list, that looks precisely like the list I initialized on line 1, and it contains the numbers 6, 5, 7, 8, and 10. So let's keep going. I'm going to click forward again. That steps over line 2, and the result of that is we now see a sum variable in the global frame, and its value is now 0. Now let's step over line 3, and now we're on line 4. So now we see a score variable, which was declared as part of the for loop. And in the first iteration of the for loop, the score takes on the value of the first element in this list, which is 6. So let's keep going. As we step back to the top of the for loop, we have executed line 4, which adds score, which at this moment is 6. It adds that to the sum. So now sum is also 6, which is updated from its previous value of 0. So let's keep going. And now score takes on the value of 5, which is the next number in the list. And if I step again, 5 gets added to the sum as well. And now sum contains 11. So this is how sum gets accumulated to eventually containing the sum of all the numbers. So let's keep stepping through. And I see that sum steadily increases in value. And now we have stepped out of the for loop onto line 5. So line 5 calculates the average, which takes the sum, which currently is 36, and it divides that by the length of scores. So which should be 5. So if I step over that, I get an average of 7. So that's actually not precise. I think the decimal point has been removed. That's because in Python, by default, numbers are integers. And when you do division on integers, you're left with integers. So that's a detail that we need to probably fix at some point. But for now, we're not going to worry about it. So stepping through the last line, line 6, we're just going to print the average. And the program output says average score is 7. Python Tutor also has a feature which allows shared sessions, which means multiple people can connect to the same code and walk through the same code at the same time. As you can imagine, this is really useful for mentoring. So Python Tutor is a great way to get a deeper understanding into how your code actually works. And it's so easy, almost too easy. And remember what I said about easy? Because easier is not always better. So here's an exercise that you can do for yourself. Instead of walking your code through Python Tutor, you can actually walk through the code by hand using just pen and paper. So this is a program that I wrote by hand. It's very similar to the last program. The difference is this one, instead of calculating the average of a set of scores, it's actually just going to find the highest score and print that out onto the screen. So let's start at line 1 and execute line 1. So line 1 creates a scores variable and sets its value to a list of 3 numbers, 6, 5, and 7. So I'm going to create, in Python Tutor, they call it the global frame. So I'm going to create a frame with the scores variable in it. And I'm going to also create this pointer thing because lists in Python are objects and objects live in a different space. So I'm going to create a 3-column cell for this list that contains the number 6, 5, and 7 and scores point to it. Now let's go to the next line. And on line 2, we're creating a variable called highest and we're setting it to 0. So let me create a new row for it. So highest is going to have the value 0. Let's move on. Here we have a for loop looping through each of the scores. Each iteration of this for loop, this variable score is going to take on a different value in this list. So the first time around, it's going to take on the first value, which is 6. So now I want to create the score variable and I want to set its value to 6. Moving on to the next line. So this next line is an if statement, and depending on whether or not the conditional clause of the if statement is true, it could either move on to the next clause, the consequent clause of the if statement, or it could just bypass it altogether. So the question here in the conditional clause is highest less than score? Well, the value of highest is 0 and the value of score is 6. So is 0 less than 6? Well, yes. So we move into the consequent clause of the if statement. And this statement simply assigns the value of score to highest. So the score is 6. So highest will take on that same value of 6. Now we're going to move back to the top of the for loop because we're not done with each of the scores. We have just gotten done with the score of 6. Now we move on to the score of 5. Now, is highest less than score? Is 6 less than 5? No. So if this conditional clause is false, then we skip this next line. After skipping the next line, we come back again to the top of the for loop because we're not done with the scores yet. The next score in the list is 7. So we're going to set score to 7. Now is highest less than score. Highest is 7 and score is 7. So it is less than score. So we move into the consequent clause, which calls for highest to be set to the value of score once again. So highest is now going to take on the value of 7. And now, since we're done with 6, 5, and 7, we can move out of this for loop. And the next statement prints out something to the console. So I'm going to create an area here for the console, and that's going to say highest score is, and that's going to substitute the highest value for the %d here, and the highest value is 7. So that's it. That's how you evaluate a program by hand. Practicing doing this will really help you wrap your head around how programs actually work when they run. And you may make mistakes while doing this, so it's a good idea to double check your results by actually running the code, or better yet, running it through something like Python Tutor. Now, Python Tutor is great, but it's only meant for small and standalone programs. If you're building a real-world product, then that's not going to work for you. But luckily, there's something else that will do the job, and that is the debugger. Like the Python Tutor, the debugger will also allow you to step through your program line by line, and it will also allow you to inspect the values and the state of your program while it's running. In one of the next episodes, I'm going to go in depth into how to use debuggers. You know how after watching a whole bunch of videos online, you feel guilty? You feel like you just wasted a lot of time and you didn't really do anything productive. Well, I've got the antidote for you right here, because you've got homework right after this. And your homework is write a program, a simple program, say about 5 to 15 lines long. As to what that program actually does, you get to choose. Make it your own. Or you could go online. These are some ideas for you. You're going to write that program from top to bottom, and then you're going to evaluate that program manually by hand. And then after you evaluate that program by hand, you're going to run it on pythontutor.com to see how well what you did by hand matches up with what the machine actually does. And post your solution in the comments, and I will actually look at them. Thanks for watching the show. See you next time.